explaining what you remember about type alias and type algebraic. Especially because type alias only have text instead of text and type. Margita? Are you there? Margita? That's cool. I click the button and then you don't talk. Margita? Okay, Margita is typing. Internet went down. Okay, that's cool. Okay, so in the meantime, I will explain what I did offline because I did a fair bit of stuff for the archive. So I fixed the parsing. Now it works like this, right? Because the variable generic was broken before when we were trying to parse anonymous records, right? Which are still not implemented because I lost the code for that parsing. Because I didn't stash it before resetting for master, but that's fine. And then I also added block comments and the capability of commenting lines. So now we also have that. And as far as I can tell, you also can use special symbols to name variables because now we also have the isask filter on it. But we are also not allowing to have delimiter in the names as well as the enter. So that's pretty much what I changed. Aside from that, I also fixed the repo, although I don't quite remember what the problem with the repo was. But now it is working as intended. I definitely don't remember what was the problem. Maybe I should watch some of the recordings because I definitely don't remember. But it is working. And because I don't know how to test it to make it break, well, I'm assuming it's working. So today I was discussing with Mageta about doing.
Hello. Can you hear
Doing
me?
type alias. No, I was just telling for our future selves what is the purpose of this.
Okay. Sorry, man. My internet is kind of. I
Okay,
hope
that's
it
fine.
uploaded the video.
That's a good question.
What happens when?
And
Oh no, I have to upload again,
no,
probably.
you don't. You don't. It is uploading.
Hmm.
Probably you
Okay.
uploaded to like a local server in São Paulo, and now the server is uploading to Google servers or something.
Thanks for exposing my location, Amos.
No.
Live.
All the servers in Brazil go to São Paulo.
Thank you for exposing me that I'm in
You
Brazil.
expose yourself.
Not that I care. But anyway, what was I saying? I even forgot.
I was asking why the heck you guys added type alias with only text instead of text and type.
Because the type has just a text. Like we're storing it on the environment. So this is just a variable.
We are just storing it in the environment.
Yeah, like you don't need to clone the type, right? We're just like
No, you need to
storing
clone it,
it.
at least its name. So if I do
Yes, that's the
this,
name.
no, but
That's the
if I do
text.
this, def alias and I do
Hmm.
name equals a string,
Yes.
you need to save two things. You need to save this to know
Yes.
where to replace, and you also
Yes.
need to save where the heck
This
I'm
is on the
referencing.
environment.
No, I need to save. You need to save
Dude,
this
go to
relationship.
go to the typer.
Go to the type, and you can join by the way. I already sent the link there.
Go up there. I will join. Go,
In
go,
type
go.
application,
Go up.
abstraction, condition,
More.
or
More.
elet
More.
plus, elitro,
Go on the record,
variable,
man. It's up there.
record.
No. On the record, we are not this record.
Oh,
On the record
this.
of yes. So we have an alias context.
Yeah, but
So there
you're
is the
not
relationship.
mapping it, saving only the alias, dude.
Dude, you are. You just need the text. That is the type. You just need the text.
Wait. So wait. So the
Because
parser who
what
stores
is
this
the def
information?
alias? Yes, no man. What is the def alias?
What the heck? An alias is a relation between a name and another name.
How does the parser get any other type? Like any because it's a declaration. That's what I'm saying. And a declaration, I know their handle is specific and they get inserted already on the environment. But I think what you're saying is okay. How are you even storing the information to put in there to begin with, right?
Yes.
Yeah, makes sense. I didn't think of the parser because the parser needs to build that thing, that type, right? And then it needs to store there. So yeah, you can put it there.
Yeah, so it's basically going to be a copy paste of def fun, I guess. Yeah, here. No, declare type. Oh, so this is
Yes.
where. Okay.
So yes, but I don't
Okay.
think we're. Are we using that? That's my question. On the parser.
No, we
Oh,
are
we
not.
don't
No,
have
we
the
are not.
parser for that.
We are
No,
not.
but we can. No, what I'm saying is like declare expression. That's the thing the parser spits, right?
No, well, the parser spits a list of any of those.
Okay, so it's fine. So we don't need to add on the type up there.
No, yeah, now you're correct. So the parser will make the relationship, and then when we are adding things to the environment, we only gonna save the key to the map, which is this.
Yeah.
Okay, that makes a lot of sense.
Okay,
You can do that
another
for the
thing
left.
we
Why not?
discussed was on the algebraic types. Let me just mention this so
Mm-hmm.
you see where we're going through. So the algebraic types, they're kind of weird, right? Because you should basically get the members of the union. They are part of one type, but we are gonna mimic the Haskell one. Like you have the Okamo F sharp one, right? Which is just a tuple. There's only one type in there, and there's Haskell's, which is like a function, right?
Yeah.
So for
So the
example, you
constructor
have
will be a function.
yeah. So in F sharp, it is also a function, but only if it has one. Well, but it can only have one, so it's like always a function of arity one.
Oh,
So
okay. Yeah.
in Okamo, it's
Okay.
nothing.
But
It
anyway,
does
oh,
not.
wait. Before you continue, now this comment makes a lot of sense because this is
What is this
saying,
comment?
oh, this we need to make proper error
Oh yeah.
messages. We need the relationship to be
Yeah.
instead of being in the map. We need to be to have them together.
Mm-hmm.
So okay, so now I understand your, but I think because of the proper error message, we should add text type there.
Yeah, but I don't know how to even do the proper error messages yet, so
No, but
that's
we
a whole
will.
other issue.
It's not a problem. Okay, so continue. So,
So okay, so when we are actually doing the evaluation, no, sorry, we're evaluating the declaration of the type of algebraic types. We generate functions in the environment with they basically like represents the unions, the union cases. So for example, when you do look at the type ADT up there. So you have a unit which is like nothing, right? So what would be a function unit? Well, it is just receives nothing and it spits a type. Uh, well, that's bad because the name of the thing is type, but anyway, you got the idea. So it spits a type, right? If you do something on a T arrow, then it spits a function that picks a type, another type, and spits a type. So you see, that's what we plan to do. And then you just attach them to the names, and that's it.
wait, can't we just make one function per, like, if I make a record like this,
Mm-hmm.
um,
It's not really a record, right? But I get it.
no, wait. So let's, I don't know, ax, and then we put this, and then we put this, like that.
Mm.
What is the type of the function record?
Well, of the function record, the first case you mean. So
Yeah.
that would be
So
just a
no,
record.
not the first case.
Yeah,
Each,
that's
as
a
far as my
function.
understanding goes, each record generates one single function that does
Dude,
this.
rename the records to like ABC. I think it's confusing.
Okay. ABC.
Yeah, the record on 159 57. Sorry. Yes, that. So
This.
what is the type of ABC you're asking?
Yeah.
No. Wait. Keep the data record. Those are two different things.
Yeah, this is the
We're not.
constructor of the record.
Yes, we're no, dude. Like what we're doing is not the first thing is just a label. Like the first ABC. That's just a label. The second is the function.
Yeah, no, this is they can be different. That's fine, but that's very
Yes, okay.
uncommon.
Just I know, but that's just for like avoiding confusion. So the
So
ABC is the thing that will make the function.
okay, so
And the
this
function, yeah, and the function for that should be just the record in our approach.
the function for that should be just the record. What do we mean?
Well, just the type record. A x with an integer, y string, and z a string. It's not a curried function.
No, but in Haskell it is. That's what I'm
Well,
trying to
it
say.
might be, but in our approach, that's not. That's what I'm
Oh,
saying.
okay. Wait, so it's not gonna be curried. So that's good. How that's gonna work?
No, it is curried on things that are not records. Like if you have another record there, then it's curried because you have now two things.
I'm confused.
Let me join there. Oh man, where did you send the thing? Oh, here. Let me open this Microsoft garbage.
That you are now professional.
Oh man, I can claim being a disliking Microsoft and being a Microsoft MVP. Okay, so where are you? Here. So think of this: data ABC. You do V's in Haskell, I guess. Oh man, what the heck? X, and then like I don't know, string, integer, y, oopsie,
Yes.
y,
Yes.
I don't know, rational, whatever.
Yes.
So you have two functions, which is the first is an x that has string, true integer,
That returns an
true
ABC.
ABC.
Yes.
The second is
Why?
rational,
To
true
ABC.
ABC.
Yes.
On that case of the record, the ABC is I didn't want to copy this, but anyway, this is like an anonymous record, so this
Oh,
true a
now I
record.
understand.
So if you have another record here, then it is this.
Why would we prefer doing like that? Just because we already made the anonymous records?
First of all, I think it is weird currying a record. I already think that's weird.
No, I'm not. Okay, that can be weird coming from an F sharp and OCaml guy, because you guys treat records in a
Man,
different manner.
yeah, but then like I don't know. Like okay, like you curry this, but then it goes in order. I
Yeah, the
guess
order
right. It wouldn't
matters.
make
The order
sense
matters.
otherwise.
The order totally matters. Well, for me it's fine. I just wanted to understand. So what we're doing is we are reusing the anonymous record abstraction that we already made.
Yeah.
Okay,
Actually, we
that's cool.
dropped the anonymous record to just do named nominal records all the way.
Oh, okay. But anyway, we can try the F sharp OCaml approach. That's fine for me. I just
Yeah,
think
it's
it's
like
more
a mix,
useful
right?
to
No,
the constructor to be a function like this.
no, dude, it
But
is a mix. Like this is still currying, but it's not currying the record. The record is only one thing.
oh yeah, that part I got. But that's the thing. I don't. It's not that it's not. Both are useful. Both methodologies are useful. I'm more accustomed to have the constructor being a curried function like this, because then we can do the parser combinators a lot more easier. Because for instance, if you take a look on the parser of expressions, take a look on line 268 in the E-type abstraction thing. We have
Yeah.
four things here, and when we do the parser, we just fmap this because this is a function that receives four things. So that's how we explore the constructor being a function. But
But that's not a record, man.
no, that's not. But it could be. That's not the point. It could be a record. We just didn't want to.
Yes,
Anyway,
but if you want a record, but that's what I'm saying. Like, if you want a record, it implies that you want some structure. So if you want a structure, why would you go with like a function?
well,
That's the thing that kind of set me down on this.
Wait, the
of his way
question
of
is, if you want to
converting.
have a record, why you want a
It
function?
doesn't make sense to me that to allow you it's just to me it's just sugar. Like it doesn't make sense to
Oh, it is
convert
sugar.
a.
Of course it is. It's just a useful sugar.
I don't like
Of course it is
this.
sugar. Um, for type. Okay, but let's start with the alias. I think that's easier. So show
I'm pretty
type.
sure we're gonna break everything, but that's cool.
Oh, of course. That's okay. Okay, so let's start with the type alias. So when you have a type alias, let's start. Where do you want to start today? We have all the same stuff. Actually, we have more stuff because we need to define what is substitution for that, and what is reduction, and what is kind checking.
I just search. It's like a variable.
Okay, so for the first one, I think is the type substitution. So let's go here. Line 61. The
Let me
alias.
follow you.
Okay. So what is to make a type substitution in a type alias? That sounds important.
What is a substitution? Well, you just get the thing. You already have it though, so you just substitute on the type. That's it.
You just substitute in the type, you say.
Yeah, you just recall the function recursively on the type.
Okay, so it's gonna be the same name, but you just apply type substitution recursively with the placeholder with the type twice prime.
Oh, we discovered a cool function. I think you might know. The bfunctor second. I think it's somewhere.
Bifunctor, yeah, bifunctor is very useful. By map.
Search for a second, you will see it. I don't remember where it was.
Wait, but now I have a question. Oh, here it is, second.
Oh, it's up there. I didn't even see it.
Okay, so but I still have a question though. So can you say again? We want to go to the type that we are holding in the alias, and we want to apply type substitution. Is that right?
Yeah.
Okay, so it's gonna be type prime and type prime twice. Yes.
Awesome.
Okay. So now the next one is type reduction. That it lives in the typer. So let's already type check this thing. So what is the type check type alias? So type check expression.
Oh, you just
No,
get
this
the
is not an
thing.
expression. This is not an expression. This is a type declaration. And
Yeah,
you
so
guys
you
already
don't
did it.
check.
Okay,
It's
so
already the thing. Yes.
yeah, so you have a type, you have the declaration of a type, and then you kind
Let
check
me
that thing.
see.
That's
Yeah, we're
okay.
just inserting with the name in the context,
You
checking the
pick that
kind of each
kind
one of
and you
them.
add that to the kind context and you add that to the alias context as
Yes.
well.
Okay. Now yes.
I don't
Okay.
think this is enough though. I
This
am
is
pretty
what enough?
certain enough. I think we need to add to the variable types, don't you think?
Not really. This is like this is the same thing actually. We just know that we will search the type that represents on the alias context, but it could be there as well. Just yeah, I don't think it matters much.
Wait, alias context. You guys made another context for aliases.
Yes,
So
that's
how
what I
the
was
heck are we
saying.
gonna know? How are we gonna know? Oh, we need to
Hmm.
search this context instead of the variable types context. How are
Well,
we
if
gonna know?
it's a, we know if it's a variable type,
We know if it's a variable type.
don't we? I think we don't.
Uh,
We should. Like
that's a
when we
good question.
eval something with for all something like this, we know that thing is a variable type.
No,
That's the
no.
only
For
case.
instance, go to line 79 on the typer.
Yes, I
We are
see.
type checking an e variable.
Hmm.
This e variable, we are assuming that this label exists in the variable types context, but this may be not correct. Maybe this label exists, but only in the alias context.
What was this variable? E variable.
Yeah, because this is an expression, right?
Wait. Yes, this is an expression. This is not a type variable. What is that context then? I don't know.
That context is the context that, like, what is the type of plus? No, not plus.
Oh, so it's like for random expressions. It's not
Yes, it
for
is for
the.
random. Yes.
Oh, it's not for types itself, is it?
Um, I don't think so.
Because it is a reference to other types, not a reference for like things that get evaluated and thrown in there.
Well, anyway, so when should we take a look on the alias context? Can you give me an example?
Well, if you are evaluating something, let me see. So think of where you would put an alias. Anywhere where you have a type.
Everywhere that you want to do the type comparison, you need to take a look on the alias context, in my opinion.
Everywhere you find. Because think about this, like what is the type you would put in the other places? Like for example, let's see the variable. So you do a variable, if type check the variable, so you look up there, and did you see it's a t alias, right? So if you see it's a t alias, what do? You
No, you
check on the
never.
other
No.
thing.
But that's already wrong because we are
What?
looking into the wrong context. You see, if it's a type alias, we are done. We're gonna throw nothing. We're gonna say, oh, unbound variable in the environment, because the alias lives in a different context than the variable ones. So, I if the alias for
Dude, I don't know how this is made. I don't know what we were doing, but then it would mean that we would have to do another.
lookup, that sounds like another lookup to me.
Okay, dude, but the problem is we would have to add the reference on the variable types for the other thing and then search on the alias context, or just merge those two in the same. Like, I don't know which approach to take. I don't know what Nathan considered thinking of that.
Yeah. So, from my point of view, if I was doing this, especially looking at the type signature of the variable types in the alias context, uh, the my initial idea, maybe I'm missing something really important, but my initial idea would be to merge the alias context with the variable types.
Comment this.
Um, but I want to try to think
Comment,
in
man.
which, no, we can comment, that's fine, but I
Does,
want to
no,
know.
because, dude, it doesn't make sense. Like, it is the same shit. Like, we would basically just have a reference, which is like, for example, ABC to integer. So
Mhm.
the ABC is the type now, but it's just a reference, right? So, but then I'm thinking the text there is a different text.
Well,
Can
it
you
is a
see
text
that?
with a capital
No, no, no,
letters.
no, 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 no. What I'm saying is, think of what is the variable types that you're looking for there. It is the type of a variable, right? So what is the thing of the variable you're going to look on the text? Well, it's going to be on the like the name of the variable, right? The
Yes,
label.
yes.
On the other one, it is like a variable, but it's a variable for a type. So it's the alias thing. So it's kind of different. It is not the
Oh, okay. So
same.
it is different. It is different. You're right. Okay, but then the question remains the same. Okay, so we have three environments: one for variables, one for kinds, and another one for aliases. That's okay. Now we need to figure out when we should look
Yeah.
up to the
So
alias context.
let me think here. So we how do we insert before thinking of this? How do we insert things in the alias context? Sorry, in the variable context. How is the name of that? Variable types, I guess.
Yeah, variable types.
How do we even insert things there?
Okay, so how does that work? So when you are declaring an expression, we do nothing in regards to that, right? So we just type check, do nothing. But if you are declaring, for instance, a value,
Mm-hmm.
then we type check that value with the current environment. We get that type, and then we are mapping. Oh, when you see this name, that is for, I don't know, X or Z or Y or something like that, you're gonna look for the environment and you're gonna get this type. That's pretty much it how it works.
So let me see. So
I
when you
think that
get
the alias context matters in reduction.
wait, let me think here. So when you do let's think of normal way. So when you do let x equals 1 2 3, that's you
Yes.
know the type already. That's an integer,
Yes.
right? So
Yes.
what you're doing there is that you evaluate what is the value of that thing. You get the value, and then you already insert to
The
the
x and
attaching
the
the
to integer.
variable and the integer. So
Yes.
when you eval a variable, you already know that you should look in that environment and say, okay, that's it. So I think we should add a rule in there, because think about this. What is an alias, right? An alias, how we would type check, an alias. Think about this.
Yeah, for me, type
So
check an alias, you just look into the alias context and figure out, oh, every single time I find this alias, I need to use this type.
yeah, but think of this like an alias just makes sense if it's shadowing another type.
Yeah, so that's
For
why I
now,
think it's just reduction. It just matters for reduction types.
exactly. So I don't think we
Uh,
should mess there, just
yeah,
down there.
yeah, I don't think type checking will interfere. Kind checking and reduction, these are the ones we should take a look at. So let's suppose that you have an alias. So t alias. So you're gonna have a name and a type. You're gonna have a name and a type.
Hmm.
You're gonna have a name and a type. Wait,
So we just reduce the type and spit it, right? Mm,
wait.
mhm.
Yeah, so this would be
No,
something along the lines of
that's
type
still not right.
this.
Oh, dude, never mind. The type returning from that would still be an alias, right? We're just reducing the last thing of it.
No, no, no. From my point of view, if you reduce an alias, you shouldn't have an alias after. You
You
should have
shouldn't
what the alias
have an.
is asking for. Oh, I am an integer. Okay, so instead of considering an alias, from now on, you're gonna be an
Yeah.
integer.
Okay. Yeah. Okay. Makes
Yeah,
sense.
but that has a problem though. That has a problem because I'm not seeing. Uh, one sec. One sec. One sec.
So we would need to reduce there, right?
Man, I think we would have to allow, not to allow. We would have to pass the environment to the reduction function again because we are not doing that. If you pay attention, right? Look, let's suppose, because right now here in the beginning of the code, what we are doing, oh, we pick that name and you register that, oh, this name is this type. That's fine, but the reduction function doesn't have access to this sort of information because it's just type to type.
Mm-hmm.
So the only way to do it would be to have the type, the mapping between the name and the real type in the type itself. Instead of having t alias text, we have t alias text type,
Yeah.
and then we just unwrap. But that's the thing. When you guys made this code, you guys didn't consider doing like that. That's why the alias context is here. So let me think. I don't want to send the environment to the reduction function. I don't want to do that. But now the question is
Uh,
how to do that.
Let me think here. So when we're declaring something, that would be like ABC and then a string, right?
Yeah.
So you attach both. So it will be ABC mapping to a string. And then on the deck eval. Yeah. This is. Ah, man, this is so.
How to do that? We don't want to pass the environment to reduction.
Yeah, I think it's already a bad design we opted here.
Well, which one? Having to pass the environment to the reduction function or making...
No, no. The fact that we can see these as the option is already a good indication of of a bad design somewhere. I just need to think, man, because even if we return, dude, like the okay, it makes sense the type check Okay, the type check is fine because it will be an
Yeah, we're not
expression.
going to change type check expression.
Yeah,
That's
because
definitely a thing.
we
We're not
don't
going to
type
change that.
check. Yeah, I'm just thinking because we don't type check declarations, right? We don't send
We
them.
don't
They're
type
not
check
expressions.
declarations. Yeah.
They're not expressions. We just insert them in the environment. So
Yeah. So
that's what
if
I'm.
we want to continue doing this strategy of passing the alias to the alias context to the thing, I think if we want to continue doing that, we're gonna have to pass the environment to reduction because it needs to do a lookup using the name.
Does it?
Yeah, because how the heck? Like we don't have this at the moment, right? You're
Because
not.
think about this.
You can
What would
construct
be?
this, right?
Yeah. Okay. Like think about this. Like when you call reduction, you call it when you want to compare two types, right?
Yes.
And then you would say, okay, the type of this variable here is an alias of blah 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 to another type.
Yeah. So forget the name
So
and just give me the alias to compare.
so when you reduce, that should already be comparable. So I think that is fine. We don't need the environment there.
No, but we need to be able to construct this, man, right? And right now there isn't any way that we.
I do think though that we should still call recursively the eval, the reduction on the other type because it could also be another alias.
Oh, that's true. Yeah, it should be this.
Yeah. With
But
the yeah.
yeah, but that's now the problem comes, which is that how when we're gonna have this because let's do the pipeline. When you do a
Mm-hmm.
def alias in the code, when you do this def alias and then you put name equals to string, the parser will parse this as a declaration of a type like this.
Yes.
Okay, so then it will kind check whatever is this, which is correct. Then we'll add the kind of this name to the kind context, and it will add name to string in the alias context.
Yeah.
And that's it. So we are not creating at each moment, we are not creating T alias. This is this, wait, this is never being created, right? This. Throughout the pipeline.
Just let me think because shouldn't that already be the declaration? Oh no, right? That's not the same thing. Where should we construct that?
Exactly. Where should we construct that? I have a feeling that we should construct that in the when we are before adding to the environment here. Like instead of name, type that we do t alias
Mm-hmm.
name and then that.
Yeah, makes sense.
Yeah, but
But
now
it's kind of redundant to
it
have the
is
name.
completely redundant. That's exactly the point, right? But do you agree? Do you agree that in the expression level, which is the ones that we are calling reduce all the time, so we have the
Mm-hmm.
list, and then we type check the list, and blah blah blah. Um do you agree that we're never gonna have uh, t alias name type because we're never checking for alias context in the type in the expression?
Oh yes, that I agree.
Then we never this pattern match down here. This is never gonna be called,
No,
right?
but we can check there. That's what I'm saying. Like, go for one expression, like an easy one. Go to a
Okay,
dummy.
go to list. I don't know,
Yeah, the thing lists are fine.
or literals. I don't know. Who cares?
List. Yeah, okay, literal.
Yes.
So
So
okay,
literal you just
what
pattern
we?
match to see
Mm-hmm.
the literal, and then we know. Oh, if that is a value of unit, then we return the type unit. That's okay.
Yeah,
But
the
there
literals are
isn't a
not
way
good one.
to redo to
Yeah,
return a t alias out of this thing.
yeah, but think about this. If you do an alias of a unit, that's still a literal.
If you do an alias of a unit, that's still a literal.
Yes.
No, that's defining a value, not defining an alias.
No, no, no. What I'm saying is this is an expression illiteral, literal, right?
Yes.
What we're doing there is matching the literal and then getting the value out of it, right? So
Yeah.
we're not okay on the literal. I don't think we need to check this. Never mind. Yes.
Yeah, no, but then the question is, okay,
Mm-hmm.
which type of expressions can you think of that we actually need to check the alias context?
that we actually need to check the alias context.
I have a feeling.
Variables. Think of variables.
Variables. Yes, so variables is one of them. So you have a label, right? And then
Mm-hmm.
right now we are just checking the variable types context. We're not checking the alias one.
Yes.
So
But then I asked the question: shouldn't the alias be in there as well? I think that's what we should do instead. Isn't that it? Like think about this. Go up there on the
oh, that makes
declarations.
sense because then it wouldn't be redundant
Then
to
it
have like
yeah
this.
exactly. So we add that
Ah,
to the eight. Yes, you got the point.
yeah. Okay, so let's do that then. Let's see what sort of things we explode doing that. So variable types. This is a name, a text with type, and then the type is this. Okay, okay,
But
okay.
then also add the alias context, right? What is the? We don't need actually, man. That thing.
Yeah, no,
It's
that
very
I'm not. Let's just remove it for
yeah.
now. We have
Comment
everything
that.
saved on GitHub. That's okay. So now the question is, what do we need to change in the evaluator? So you guys already didn't do to do add cases of a discriminated union to the context as functions.
Wait, what?
Uh,
Add cases of discriminated. Okay, this is the thing that I was talking about of adding the like the discriminated union. If it's a declaration of it, then because there are two declarations. That's what I mean.
yeah, they're actually like three, right? You can be expressing an ADT, a record, or an alias.
Yeah, but in that case, let me think. What do you do on an evaluation of a declaration of a type? Nothing.
Yeah, nothing. I agree. I totally agree with that.
So yeah, we only do the functions, right, for the things, for the unions, union cases.
Okay, so actually we can skip for now for the sake of to have something to test. We need to remember to do that, right?
Mm-hmm. Yeah, we don't
Uh,
even have algebraic types yet,
yeah,
so
we don't
let's
have
just ignore
ADTs.
that.
One sec. Okay. So okay, no, sorry for that. So
No problem. So we
um,
can ignore the evaluator.
we
There's
can ignore
nothing
the
to do there.
evaluator. Okay, so just parsing and we're done. So
And wait just a second, man. So we are adding the variable there, and we the only case where we add the alias is on the reduction. That is right.
I
Because
have a no. We also need to check. Oh, you remember me? We need to take care of type check of kind checking. Kind checking is also complaining about not having all the cases.
aren't we? Okay, I see. Yeah.
Okay,
So
so
we
t
just
alias, and then we have a
yeah
name and a type.
yeah this is easy.
Okay, so this is easy, you say.
Yeah, you
So
just
this should
pick
be
the
kind check,
type.
sending the same environment, and
Yeah.
asking for the type of the one that I'm holding.
Yeah.
Okay. Shouldn't we compare this like to star or something like that?
Um, that might be because think about this. Like, if can you abstract any type? That's a question.
Can you abstract any type?
Because go down there. What generates the only cases where you have an arrow of that thing are
Is
the
the
cases
type
of the T
application?
application
Yeah.
and the T
Yeah,
abstraction,
the
as
type
far as I
abstraction we
know.
generate one.
Yeah, so can you abstract those with an alias?
Theoretically, yeah. Not at right now because our type aliases don't allow you to have arguments. So I don't see a reason why we will have arrows. But
Yeah, so I think we can leave it like that. We just, yeah, we just,
yeah,
I think
let's
we
leave
can
it.
ignore this,
When
yeah.
we add a list of arguments to the alias, then we will have to care about doing all that stuff. But anyway. So let's now do parsing because that should be easy. So
Let me think.
I'm
Let
gonna
me think.
copy paste this.
Oh, dude, can you abstract a, oh man, can you abstract a t variable? A type variable? An alias of a type variable?
An
What
alias of a
happens?
type variable. Wouldn't
What
that be like?
happens?
Yeah. What does that mean?
Because
I
it is
have no
possible,
idea.
right? It is possible. So what happens?
I have no idea what happens, dude. I'm sorry.
Because think about this, you would shadow in the sense not of like literally of hiding something that you cannot replace anymore. Yeah, dude, that's something we gotta think about. Let's see what happens first. Let's see. And
Um,
then we start to think about it. Who is there?
Commander.
Oh, hello, Commander.
Okay, so this should be type P, and then it should be the real type. And then we just do declare type. Oh, and by the way, I already updated the REPL to have this. So as soon as we have this for typing, like parsing, the REPL should already be strong enough to handle that.
Strong enough.
Yeah.
I like the way you put it.
Okay, so that should be it. And then here, we just def alias p. Okay, we can save that as test to see what happens. Probably it will not work out of the box.
Mm-hmm.
Okay, it's
Oh, just a second.
taking a time. Okay, so it didn't work. Exactly as I predicted. Oh, okay, so this is just a matter of importing. Okay. Okay. Um. Okay, so now things started breaking. That's cool. Here, 74. Um. Oh,
Okay.
it's because we don't have this anymore.
What happened?
Where is the other place that we are having that?
Okay.
175.
Oh yeah, we had to add into other places
Yeah,
the
and I already
third.
fixed. I assumed it was correct, so I added in the repo. And now we are undoing all of those. So
Dude, these things, man, they always come back. I just like, get those things out
36,
in my
39,
farm.
36,
Out there.
and
Typer
39.
env HYZ.
Done.
And there's another there.
Are you sure?
Yes.
Yes. Here. Oh, okay.
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 Cool.
So so let's make a file. So this would be alias. So def is what are you laughing? String, right?
I don't like the equals there, man.
Well, we can change to for a column if you want.
What about infix
No,
equals?
no. Not the infixed. Well, prefixed. Infixed is already.
Oh yes,
Um,
prefix. Yeah, something
so
like this. Just imagine.
Uh,
Just think about it. Anyway,
uh,
dude, why do you cannot be modest, can you, Lemus?
what do you
Just
mean?
do a print with this shit, man.
I will. That's exactly what I'm gonna do.
Yeah, man, but you're doing a function for that. Like, that's way fancier.
And then a, and then we're just gonna call function.
Why don't you put string there to see if it matches
What do you mean?
instead of like? Okay, let's go modest. Let's go modest.
So let's put nugget.
Thank you.
Stack is X, spatula, F examples, alias. It did nothing. That's not a very good sign. So, okay.
Typering. What is a
So,
T? It's just a type check.
oh yeah, it is showing us the the typer environment, removing
Okay.
the different things from prelude.
Mm-hmm.
So this is
So
what we have there.
name
We have a name, and then we know
that
it's
is
an
an
alias name for
alias.
type string, which is what the show function is implemented.
Mm-hmm.
It should show. So, but it's not printing, right? It is not printing, which is kind of
Yeah,
annoying.
and you see, go. Can you go back there? Look at the kind. It is a star, so it got the type of the string, right? As well.
Yeah, I wonder if
Can you change to string there the print
what do you mean? Here?
instead of name? Yes, change to string.
Yeah, but the fact that it's doing like this, it
Mm,
is type checking.
yes, but
Um,
it should. Mhm. Yeah, but it's not evaluating, right? It's not
yeah,
doing
it
anything
is not evaluating. So let's do like that.
by name.
No,
Temperature to apply for all unit. That is not a function.
that is not a function. That is
Go.
weird. This is a
Can
type
you?
error. So
Oh
attempted.
wait, can you go back there? Oh, you passed the name. Just do print. Can you open the REPL, man?
Yeah.
I don't know why we're compiling if our language has a REPL. So do a alias there.
uh, oops. Def alias name. Oh, I don't know if this is gonna work in the REPL. Oh.
Okay. So now do the colon T name. Okay. Interesting. Okay, so do colon T on application of print with name. Haha. So let's go on the application type
Yeah,
checking.
application, definitely application. Interesting. Okay, so application.
The fact that we can debug with our REPL, that's just
Yeah, that's why we made it. So there's that. So e-application, I found it here. So 115. So you type check.
so we
Uh,
reduce the type on the function.
yes.
Then we pick the type and we see if it's an arrow, which
Yes.
it should be, right? And then we say, okay, that reduced argument.
Oh, this is wrong. So we didn't find an arrow because the
Yeah,
error
so
message
it's
is
not
this.
doing. Yes, exactly.
So whatever you did, it didn't find an arrow.
So why didn't it find an arrow on the phone? Because think about this. What is the? Because okay, what is the type of the print? It is a for all, right? That shadows another type.
This is the type.
So where's the for all
Well, this is
here?
the prelude. Definitely in the
This.
prelude.
So
Where
let's
are you?
see. And here, 154. Oh, what the heck?
54.
Oh, I was following him, man.
Oh, okay. No, this is an e-type
154.
application.
Yes, I know. That's what it abstracts the for all.
Oh, yeah, 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 yeah.
So let's read here. So we reduce the type of the expression with the type. So the name should be this type here, right? The name, the alias you're passing.
The alias should be the type
Oh,
prime.
hello, Nata.
Yes.
Yeah. So yeah, okay. Can we add? Oh, we cannot print here.
No, we can. No, 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 we can.
We can write a
Yeah,
safe perform IO.
because this is a transformer type. But I don't think that makes sense
Yeah, but
because
let's continue.
the error
Let's
message
continue.
is not these ones. So it's definitely new
I
application.
know, but what I'm saying is it might be building the wrong type, and when it goes back to the application, then it fails. Because this
Oh.
is just a thing to abstract the type, right? So
Okay, yeah, that makes
that's
sense.
what I'm confused. So let's see, for all, and then okay, it is a for all, the print, we know. And then what do? We pick the kind. Okay, what is the expected kind of the type? Yeah. And then we see if it matches with the kind of the for all. If it does match, then we just do return of the type substitution. I think I know where the problem is. We do the type substitution of the type on the body of the thing. So let's go on the type substitution. I think the error is here.
Type substitution is on the types. Yeah.
Types.
Type substitution line 39.
So we're doing substitution with the same name, building the same name, right? Doing a type substitution on the type.
Yeah, just
Yeah.
passing it around.
Are we passing on the right thing?
That's a good question.
Because the target is the second thing. Oh no, dude, it's the opposite.
Oh yeah.
Oh, okay, you can just do this, I guess.
Yes. That's a great
Yeah,
part
okay.
of it.
Okay, let's see.
Okay, so just one sec because I am adding the print. That should be enough.
If that was it, it was a very tricky miss. Yeah, open the repo again, man.
Nope, same thing,
Okay,
but we can
still
do
the
the
same
REPL again.
shit. Yeah, but at least now it should print, right? The thing.
So print. Oh, I need to do the def alias again.
Oh yeah.
Oh no, I
Don't you have a history?
We don't have a history internally for this. We would have to create
Okay.
a file or stuff like that.
Oh yeah.
Alias. Okay. So if I ask for the type of print
Print
name,
name.
same thing.
Mm-hmm.
I don't think
So
it's passing to there through there the type
so
application.
where did we put the print to begin with?
We added into the first line of the type
Application, right?
Yeah, here.
So when we
156.
press the T, yeah. So why didn't it print? It didn't even reach there.
Yeah, it didn't reach there. Yeah.
That's strange because okay, it is an application. Can you add that on the application instead?
Yes. So
Let me follow you.
yeah, here.
Yeah, there.
So let's add a few. So we have fun,
And the arg.
arg, and I also want to see the reduction type. Reduced fun type.
Reduce font type. Also the reduced arg type here.
Arg type. Oh, okay.
Oh man, what the heck? Reduced arg type.
Yeah, that works.
Did you
is here,
save
by the way.
You didn't save the types, by the way. Wait, was it the problem? You didn't save the types.
The types? What do you mean?
Oh no. Why do I have the? Can you follow me?
Where are you?
Click on my name on the arrow.
Yeah.
Yeah, you can see.
Yeah.
This file is not saved.
Oh.
So okay. Yes, try saving
That would
it.
explain a lot.
Let's try Lums.
Okay, so let's first import the alias. And then let's ask, okay, what is the type of name? Oh, it prints stuff this time.
Yes. But you compiled. It didn't compile again, right, after saving. So
No, I
maybe
did.
the substitution is not working. Okay.
No. I will do it again, just to be sure. Oh no, I didn't. Okay, so you're correct.
I don't know if that's the issue though, but
I also
that
have no
was one.
idea.
That was one of them.
That definitely, definitely one of them. Alias, and then we do t print name. Yeah, same thing. Okay,
Mm-hmm.
so the print,
So the
I think it's
first
the
one,
fun. The arg is the name,
yes,
and the
the
reduction
arg is
arg
the.
type is the for all, apparently.
Wait, it parsed as an e variable.
Is an e application.
Yeah, but go back there. It parsed the name as an e variable. Is that right? Then the error
Oh.
message kind of makes sense. No, but yeah, dude, what the heck? What? That doesn't make sense.
Um.
Hmm.
Okay, so let's do the following: examples, alias, and let's ask for the type environment.
Magetta. So it is an e. Oh, it is just a simple e application.
Now I think now we are getting to the territory of now
Can
having multiple prints that are not following any
wait,
sense.
Lemus. Can you do just let me confirm something. Can you do the same but for a string instead of the alias?
Okay, so let's go there.
It will parse as a type. I'm pretty sure. No. Yes, you can keep it there.
We
Just
can
change the.
comment.
Oh yes, we can. Oh man,
We
damn.
can comment it out.
Yeah, but remove the Magetta. Remove that. Yes, this.
That will fail, I guess.
I don't think so.
That
It
it
shouldn't.
should fail.
Yes. So okay, that's what I thought. So
That
it
doesn't
is a
make any
spot.
sense though.
Wait, it printed a string.
Yeah, no, this is probably one of the prints that we added in the typer, but we are not
What?
following it anymore.
Because here's the thing that I'm thinking is happening. Okay, go back there. I'll show you.
One sec. I want to remove the print so we can have a be more confident of what's happening.
Be more confident.
Okay. So now let's build.
There's another here.
Oh, you found another one. Okay, so let's build again.
So there is another issue, which is when we parse, when we do like print
Yeah.
and then
Okay.
string. Okay, but here's the thing. Can you print the AST instead?
Yeah. Totally.
Do that, please. Yeah, so you see the string is a standalone shit of a type application. Do the same for the alias,
Okay.
for name.
We can uncomment, dude.
Yeah. That's fancy.
Magic. Just magic.
That's the issue. So it is parsing as an e variable, and then it doesn't understand it's an e type application. So that's why it fails on the for all. Then the error message kind of makes sense because it is saying, okay, we're trying to apply something here, but I was expecting a type, you moron.
Yeah, but then wait.
So that is a problem on the parser. We need to know on the parser how to differentiate between. Didn't we had different? Wait, is asking different. Didn't we had different Magetta name? Oh yes, okay. I was discussing this with Nathan. Like for type aliases, how do we differentiate them from the normal types?
It
You
should
know?
be this. We already have the brackets and the def alias stuff going on.
Mm-hmm. Yes, but there, like, think about this. The parser doesn't know when it's parsing an application.
Am I trying to parse that as an expression instead of a declaration? One sec.
Yeah, but dude, think it makes total sense now, man. Like on an application, you don't know if that thing is a type or not. Like the parser doesn't have an environment to check stuff.
No, it doesn't. But at the moment, we don't need we don't need a keyword to differentiate that because you already have a bunch of other things differentiating
No,
it.
no, dude. Like, for example, name. What is a name?
What is a
In
name?
this context, it's just the name of this thing, the alias. So you know it's a type, right?
Yeah.
But you don't know
Oh,
if
I
it's a
don't know
type when
that
you're
whenever.
parsing.
Oh, I
You see,
think I
so
see.
it will understand it as a variable. So it makes sense it's trying to do that. So I think I was talking about this with Nathan. We came up with another syntax to do like aliases. So when you call them, you should pass like something special, and then you know like when is the alias or whatever. I don't know how to solve this, to be honest, unless we just add this special syntax.
No, but then wouldn't wouldn't be necessary to have a special node for that in the
Oh, look at
expression
the
level?
Nathan saying, look on the previous examples. Take a look there. I think we
Where?
functions
ADTs?
record. Man, I have no idea. Yes, yes. Uh, we're not using any though.
We're not using, but then I have a how this solves anything.
No, it solves because then go to the parser
Go to the
and
parser.
yes, go to the parser and go to no, ignore the declarations. Go to an application. Let's say
Uh,
go to the e-type application bullshit.
oh, here.
Yeah, this for example. So what are you doing there? Describe to me.
Well, we
I know,
are
but just describe.
grabbing between the brackets. We are
Mm-hmm.
grabbing if the thing is a type of an expression.
Yes. Okay. What is a type?
A type,
An alias is also a type, but in
and
that
alias is a
context,
type.
it's just a name. Like you don't know if it's a type. It's not a special word or anything. It's a user-defined thing.
Yes.
So there's no way you would know like this. There's no way you would know that the name is actually a type. Dude, I'm pretty sure we
Oh.
solved that already. Look on the previous example. Go on the other examples. Yeah, look on the others. I
We
think
don't
we
have
have
any
one.
many others, dudes. I don't know what you guys are
Just
talking
look.
about.
Factorials, filter,
Food, fun.
functions,
No.
functions.
Functions. We have a bunch here, but I don't know if this is the one that Nathan's talking
Yeah, I don't
about.
think so. Multiple, no, I don't think so. Read, I don't think so as well.
Yeah.
Some.
Some.
No, no. That's like literally a sum.
Record.
Yeah,
I
we
think
did.
this is the one that I did with you the last time. String. Blah 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 blah.
Yeah. So yeah, man. Like, I think the easiest way to do this, like, I can see two ways. Like, we do an environment for the parser, and when you see that garbage,
No. Nathan will explode his mind if you talk about the environment for a parser.
that's a BS idea. It works. It's a BS idea, but it works. If you don't want to like add a new, how can I say? If you don't want to add a new special syntax just to handle that, it's a viable solution. Parser is already bug enough. What are you talking about, man? The parser is tanking everything.
Yeah, it's
It's
already fixed,
saving
by the
us.
way.
The parser is the thing that's saving us. What are you talking about?
It is already fixed, Nathan. Yeah, that's a fair
Yes.
point. It will not be context free. So I have. Let me try to rephrase what you said, Maget, to see if I understood the problem. So the problem is that because this is a user-defined thing, we
Hmm.
don't know to parse that as a
We
type.
don't we don't exclude that from because what how do we parse a type? We exclude it from the variables, from the user defined bullshit, right?
Yes.
From the generic variable name, I think.
Yes.
So that's how we know if something is a defined type or not. But if it's a user defined type, then we don't know because it's not in the band list.
Not necess- yeah, we can say like that is on the main list. But what we would need to do is to parse the declarations first, and then update. Oh man.
What we would need to yes, that will be shitty. But here's what I suggest: go to the let's go here. Let's invent a solution
Here he comes.
here. So what do we do here? Okay, we parse name. Oh, cool, cool. So what is name? Bang. Or this. So damn, man, this solves all the issue. This is now a user-defined type. I love it. Amazing.
Oh my god. Okay, Nathan, what would be the solution for this without using special syntax for it?
Oh, he's suggesting special syntax.
Oh yeah, he's suggesting that, but I want to know if there is a solution without that.
There's none, I guess. Awesome. I still think this is better. What do you think? Looks like, I don't know, declare ABC, like I don't know.
It looks okay, Maggot.
Looks like these in SQL, like variables.
Okay,
That's it,
okay,
man.
okay. Let's assume that we use special syntax for it. So how does that work? What we
So
need to
go
change
to
for
the
it?
declaration. Go to the types on the
Types.
yes. Okay, and then when you parse a type, so let's make a type alias
Okay.
parser. I can type as well, man. What am I doing? So okay, type alias. Oh, type alias p. No, just this, right? So okay, let's do a do because I can think without a do in Haskell.
Okay.
So, so okay, if we see the same thing as this, let's just copy this because it will be actually the same. But we just change
Uh,
this to a t-alias. We don't need to wrap in the name, I guess. Is it just a text,
oh
right?
wait. A type variable parser generic. It requires the string to start with this.
Yes, exactly. So that's what I'm saying. It
What
should
the
be
hell?
this. It should be.
That doesn't make
Uh,
sense, dude.
it should be a string. This, this, or these, whatever. I think I prefer the at. I
No
think
man,
it's better.
it will be at bang, and then the
Why the
name.
bang? Why the bang?
Because the type variable generic parser requires one.
What?
Yeah, this was a decision that we made a long time ago. If
Okay,
you want
can
to
we
have
parse
just
just a
names, it's just
generic
this.
variable?
Yeah.
Can we parse? Yeah, okay, that's fine. That's it.
Yes. Okay, there's a problem though.
Hmm.
There's a problem, which is that the type alias. Remember that we changed this because of the reductions.
Oh, yes, 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 yes.
So we
So,
actually need to do this and then parentheses
no,
and then
wait.
applicative and then
Hmm.
um,
No. With what? We don't have anything here. It should be just a type. This thing itself should be a type. That's the problem. It should be
this
like
thing
t
itself
string.
should be a type.
Yeah, because think about this. You don't have the thing here, right? The At this point, you know when you do a def alias of like name string, you know that this type, this name here is a string, right? But when we are using it, you don't know what that is.
Yeah, we right. That's why right now the parser is assuming to be any
This.
variable, which is correct. Should be like
So
that.
this, yeah, but this alias, from what I know, we're doing a name, right? Sorry, like it should be like name, right? And then string.
Yeah.
But we cannot do this.
Yeah, but if we remove the string from being like the companion of the t alias with the name, that would make reduction requires the environment, and then we would have to add the alias context all over again
Yeah, I see what you mean.
and blah blah blah.
Yeah. So
That's a decision.
you know what I suggest, right? You know what I
No.
suggest. We can make another type, another another type, another T
Oh my
alias.
god, dude.
So we can make a
That's
T
so
alias
cursed.
two. Can make a T alias two that just has that one. So that's it.
Oh my god.
T alias placeholder. Nathan knows what he's talking about. T alias placeholder. That's it. Okay, I will go have dinner. I'll be back. And then when I'm back, Lemus, I want to see the environment on the reduction. I'll be back.
Crap, dude. Ah, ah. this needs to be a t-alias. But, oh man, t-alias placeholder, that's so bad. Holy but Jesus. That's so freaking bad. Uh, uh, okay, assuming that we would do like that. Assuming that, not that. Oh my god. Type alias. Yeah, it would work like that. So then the question becomes, um, what do we do with that? What do we do with that? Because now, this expression here, an e-type abstraction, someone, somewhere will have this thing now. And now the question is, how the heck, where? Unwrap, you say. E-type it would be type application, I guess. Oh my god. A bunch of people, you say. A bunch of places. Oh no. I'm so sad right now. So fucking sad, dude. Okay, so I guess we would have to add back the alias context regardless. Because we were trying to get away of that. Get away with that. Is the trickiest feature so far. I don't know. I don't know. Probably. Yeah, probably. I would say that the jankiest, like the hackiest one is the operators. But we're gonna have to change those at some point. It's not tricky, just bad. Yeah, it is tricky because we wanted to make we made them because we didn't know how to make them properly with native functions. So they are kind of like a band-aid solution. It was tricky to like how we make arbitrarily non-binary plus. Like we want to have a list of things to sum. But how the heck are we gonna do that with the older approach? And we couldn't. Well, maybe we know how, but we have to change that. I've not changed this right now though. My Geta is crazy. I'm so disappointed though. We're gonna have to change a lot of places just because of this. Like which places? Do you know a short list of those? Oh man, so bad. Nope. I don't know. I kind of want to parse the anonymous record just because it's easier than that. Um, because I lost it. I lost the records though. So yeah, that's sad. But there's that. Oh, so upset. So upset. If we want to make the parser context free, we do need to make in that way. If we had an environment to the parser though, that would be very, very easy. But that's just cursed. uh, hmm. Well, let me show you, Nathan. Look, this is our print. Take a look. Not print, sorry. This is our comments. What am I saying? And both of them works. I fixed it at the same time that I fixed the parser. Um, so right now we can actually have functions that use the Lisp convention. Look at the minus in the middle here. It's not interpreted as a minus. Ha ha ha. I'm assuming this will make the parsing of anonymous records the easiest as the other ones. as easy as the other ones. It was just my get style and not reading documentation, so very very easy to fix. Oh wait, there is a way. Wait. There is another solution to this problem, Nathan. I'm not saying I'm recommending it, but there is another solution. So here, if we get a nothing when trying to search for any variable in the type checking, we could just do a lookup into the alias context. And if that works, then we know. That doesn't work, you say. That doesn't work. I don't know, man. It really sounds that it would. I'm actually kind of tempted. Alias context. So this would be a map of a text to a type. Wait. We are already adding here. We changed the code that you guys made, by the way, because I already forgot the explanation, but there is an explanation for it. What is the error again? I think I'm forgetting it. Attempted to apply a value for all. Oh yeah, that will not work. Okay, that will not work at all. Because the problem is before this point of the timeline happening. This problem is because we are not evaluating this as a type and is an e variable. This is changing what the classification of this is to any application instead of any type application. So yeah, this needs to be solved in a parser level. Fuck. Ah, so annoying. Oh man. I'm so disappointed right now. uh, um, so let me think about it. So now that we added this def alias, yeah, because this sort of changing the code of like, oh, we need to have a placeholder for the potential, not the potential. We are kind of trusting the user, right? We are trusting that, oh, if you're adding an at before the variable generic crap, this is because you defined that before. And that added a placeholder for the t alias because now we have to have both two, a t alias that is not the t alias that should be there in the first place, and another one for the placeholder so that the parser doesn't screw us over. So bad, so bad. But okay. Okay.
That's not how it works, man.
That's how my get explained it to me.
Oh, because, for example, if you are saying that, then you are also saying, oh, we are relying on the user to only use variables that were declared previously. So, and we don't say that, but it's the same case. So the thing is, you have an alias placeholder. So when you can have that somewhere, you do some kind of unwrap that will transform in the other. If it is not in the environment, then you have a neighbor of an defined alias.
Wait, so can you repeat that? You need to transform one in the other, you said.
Sure. Because why do we need the other?
We need the placeholder is because we need.
No, the other.
Oh, the other is in order to be able to do comparisons, I guess.
And everything is easier if you have the type there in place, right?
Yeah.
Especially those other ones that you don't need the context in the function. And also, you avoid some weird problems with reference. But sure, that's the one that you need. The placeholder is only because that's the only way for the parser to know, right?
Yeah, this is the only way the person without having an environment, right? So
Yeah, what is not an option. So what I'm saying is, where you can have a placeholder, so where you have a type, you do some wrap function that if it is any other type, you will just return it. If it is a placeholder, you look in the environment and then transform in an alias with the type inside. If it is not in the environment, then it's a undefined type alias. It's an error already.
I have a question. When we would be doing this lookup into the in the
I guess
environment?
that every time you see a type, man,
Everywhere you see a type.
almost everywhere, something like that. You have to go through all the code and take a look, man, and reason about it. That's ad hoc, right?
No, I think we're gonna have to go back to the approach of having an alias context and stuff.
Of course. How can you do without that?
Well, because before when I was talking to Mageta, I said, oh man, if we add an alias context, we're gonna have to pass that around to the reduction, and I didn't want to do that. I still don't want to do that.
Uh, I don't see. Can you show me the reduction thing?
Yeah, here, it is this.
The reduction. Yeah, it doesn't make sense. Just because you have the context doesn't mean you use there. You will need to use there if you use only the reference one that doesn't have the type inside already, the alias.
No, but
Since,
it is possible to the reduction to find in a placeholder in here.
but it you never do it.
What do you mean?
You never do it.
I'm not understanding what you're talking about,
It
because
you never happen in practice.
it will never happen in practice, you say. So I should be able to just alias placeholder, and if you find this, I can
Error.
just say error.
Oh, wait. Wait. That's the reduce, right? That's not comparison.
There's no comparison
Uh,
yet. We will go
okay.
there.
Reduce type. What are the cases? We do that before the comparisons, right?
Yeah, we do that before comparisons.
Yeah, I'm guessing it would never happen in practice, man.
Okay, so this should never happen. Something is broken. Okay. Now kind checking, I guess. The same scenario. Is that correct?
Wait.
We don't have aliases that you can pass arguments. So we are not doing like, oh, if we have an argument, should be an arrow k or something like that. I decided with Mageta to just call kind checking on the.
Wait, can you repeat that?
Yeah. So at the point that we're gonna, well, that's my understanding. Maybe I'm just crazy and I'm wrong. Uh, from my understanding, at the point that we have aliases that you can pass arguments, like this, like that, then the kind changes as well.
Okay, I'm back. So what happened?
I forgot what you mean, but.
Okay, you're adding a placeholder.
Yeah, unfortunately, I discussed with not try to not do that.
Oh man, type 2. That's so.
Lamos, I think it's the same thing for the normal type alias. You just get the name and take a look on the kind environment. Because every time you declare a type, you add the kind in the environment, right? So it should be there. If it's not, it's because it is like undefined, right?
Wait, so I should grab the kind of the thing that I am, like the name. I don't know, name and
It's that
string.
exact same line.
Is exactly yes.
Yeah. Oh
Uh huh.
wait, what? If wait, kind check. Oh wait, dude, that is something weird there. I guess you should be checking the context.
Oh
Yeah,
yeah,
we
we
did.
already added this into the context, right?
Yeah, that's what yeah. So yeah, in both cases you need to just check into the context.
Just a lookup, I guess.
Because since you declare, right,
It's
then,
exactly a
well,
ct variable. So this is just that. So the lookup of that name in the context. And then you say and if you don't find in it, then you're gonna
yeah,
say
type
unbound
variables,
type,
right?
and then
It's saying type variable there.
yeah, type alias in the
Oh, dude, we
environment.
we have a person on the comments
Oh
in
really?
Twitch. Let me read. Llama Yamaman 7U says, "Hi, I want to offer promotion of our channel, viewers, followers, views,
No, that
chat
sounds
bots.
like marketing stuff.
The price is lower than my any
No,
competitor.
no, yeah, that's
The
just
quality,
marketing.
yeah, it's marketing.
Okay,
That's
anyway,
all
so
bullshit.
what happens? What happens if the thing is in the context?
Well, then it's returned, right?
Then you just return the kind, right?
Yeah.
Kind. Okay. What about if you find a placeholder to kind check? That should never happen, I guess.
I hope it doesn't. That's weird.
Not the. Do it is the same? Okay. No, wait. Which one do it is the same? The lookup in the environment or an error? Both alias use the same code.
Doesn't. But it shouldn't even reach there, man. Like it doesn't make sense. Yeah,
Yeah,
I
I'm trying
understood.
to
Like
understand why we would want to kind check a placeholder because in my
supposing it does, then it makes sense to do the same. But I don't think it should be there to begin with.
In the case in which you always unwrap before doing anything else, including kite checking, it will never reach there. But if
Mm-hmm.
you want to change the order, then it costs nothing to just add there.
no, but I will try to do the replacement before calling the kind checking, so this should be an error.
Yeah, then you can just error.
This should never happens. Something is broken.
It should never happen, right?
This should never happen. Something is broken.
Something is
Kind
extremely broken
check.
in their Welsh town.
And the other one, something is
That is
broken
their
in
worldview in German, but I
reduction.
don't speak German. So
Okay. So now that oh my god,
you're complaining, Linus.
this is gonna take so fucking long because of type check. Ah, okay.
Well, wasn't it easy, man? It was easy.
Type. We need to add back the alias. Magita.
We need to add
The
back the
alias
context.
context. Yeah.
Let me see why.
Then the question becomes. Oh, that's why we don't need to pass the environment to reduction, Magita, because when we have the placeholder, we can just check the environment and then create this guy. You see?
Mm-hmm.
Because we're gonna have access to the placeholder that has a name.
Mm-hmm.
Then we look the environment. Oh, this name is this type, and then we create this guy.
Yeah.
So that's why we don't need the environment in here. Okay, that's cool. Okay, now I guess we need to start from the beginning. So we need
So
to
starting by
make
the
that back to the alias context. Then just type here. We need to undo our gambiarra there.
Gambia.
Yeah, our hacky solution. There's a proper way of saying that in English, but I forgot. Anyway, and now we need to go one by one, changing
Workaround.
the.
That's not workaround, man. It's somewhere deeper. It entails a whole adaptability.
Okay, so now my question is, if you have a whole Brazilian coach,
Yes.
now my question is, shouldn't we make a function to do that? I guess we should, right?
I thought
Does that
everything
make
there was
sense?
already a function.
No, we need a
That
function
was
to
the
convert a
default behavior.
placeholder
Oh,
to
we
an
need a function.
alias.
Yes.
Well,
Makes sense.
I'm suggesting to do that.
That makes sense.
So let's see, isn't everything a function then? Oh, good.
Yes.
Okay, so um, find placeholder.
Do you see the integers? Yes, they are functions.
Yeah. So you need an environment. You're gonna have to have a type, which is in our case is gonna be only the placeholder. Everything else is an error.
Come on, man. I just want to do the code generation. Speed up, Lemus.
Speed up, you say. Find
Do
placeholder
it in
alias, I
parallel.
guess.
I guess.
Type,
Yeah, it's not easy to do this in parallel. What we are
not
doing
a
here.
type. What do you mean? I'm gonna type check. I'm gonna not type not to check. I'm gonna pattern match the placeholder, and if I find it, I'm gonna do a lookup. Taxman. What do you mean? What do you mean, my dude?
Sorry, it's typed indeed, yeah.
So find
Matthias.
placeholder, and then if you find, um, if you do typer env, and then do like that, then we're gonna pattern match this with the t-alias placeholder, and there we're gonna have a name. Everything else, everything else is just gonna be a return, not a return, a pure t, and then we're gonna do case map lookup of the name in the alias context of. We have a problem, I guess.
Where?
Here comes my nothing.
Oh, no, not that, no, man.
No, that doesn't
We
that doesn't
need to
matter. I'm just
recurse
gonna
from
return
the.
the type itself. Like it's gonna just short circuit if it's everything else. That's my idea. I don't see the problem yet. Can you be more explicit?
Yeah, it's because if you do something like arrow type that take the alias and return something else, then it would not get to the context. So it would do on later when I'm using that for something else, right? But by then, the type alias could have been alias to something else.
And what is the problem? It's
The problem
Lisp.
is that you would not have lexical binding.
Oh,
I needed a more
not a
explicit
shame.
example, I guess.
It's the one I gave you up there, I think.
Well, but then it would have in some places and some places not, and you would not really know
Well,
when I get it.
too bad. It's your issue, my friend.
So let me show you.
It's a feature, man.
It's a feature.
Yes.
Well, if we find it, then we need to do pure this t alias name t. Yes. So that's my idea. If it is not a placeholder, we just short circuit and we don't care. But if it is, then we do something about it. Anyway, dudes, I'm gonna finish the stream now. I have to go, so I'll finish the stream.